Hi, I am Onur Baktara.
Hi, I'm Farzin Negahwani.
Hi, I'm Berküler.
Hi, I'm Rüya Niyaz.
Hi, I'm Ercan Serteli.
Well, unfortunately, we don't have the Asimov's three rules in real life, but it doesn't mean like it's going to be Terminator in the real life.
Any useful tool in wrong hands can be scary, but it doesn't mean that we should close our eyes on the good sides of it.
Robots are simply no more than potentially very intelligent tools. So in reality, we shouldn't be afraid of a robot any more than we would be afraid of the sharp tip of a drill, for example. So if robots are programmed right and they have robust control systems and their intelligence systems are programmed correctly and they undergo proper testing, which they always do in the industrial settings, then no, we shouldn't be afraid of them.
I think we should be afraid of not just killer robots, but like AI in general, in terms of like conquering the world or destroying human civilization. But if you don't want that to happen, you can join us and help push the research in the right direction.
In my opinion, they will not steal our jobs, but our jobs will change. Same thing happened when, tractors were being introduced to farms. The people were not unemployed, only their duties and their roles changed in the job, in the cycle.
More robots means that we are going to have more opportunities, more job opportunities as maybe robotics, maybe software developers, maybe there are a lot of jobs that needs to take care of the robots in the different settings that they are working.
I think robotics is at kind of its baby stage right now, so I don't think looking at the examples that are like available right now and thinking, wow, is this like all there is gonna be?
It's all about iteration and optimization. In time, even legged robots can be programmed to walk much more properly than humans.
Well, I guess that robots can, at least four-legged robots or multi-legged robots can walk properly, but I'm scared of the time that they can fly or run faster than us.
So after receiving this data, gathering data is maybe the easy part, but the processing that and inferring something out of it like humans do is also very hard. So we have utilizing different machine learning, deep learning, artificial intelligence methods to kind of generate something similar to how humans understand the environment or feel the things that they touch.
It's basically for torque sensors and vision systems. These are the most popular, let's say, or the most basic perception methods for robots for now.
For example, if you imagine and take the example of the autonomous cars, we see that they are perceiving with cameras, with rangefinders, even they have GPS modules and whatnot. So combining these all data from different sensory inputs help the robot to perceive in the defined and expected environment.
Oh.
Of course not.
Not yet.
Not yet, actually.
Potentially yes, but not now.
In order to let a robot perform a skill, we can traditionally program the robot, but that's very difficult. And another way is to define it as a problem that can be optimized with a reward or something.
We cannot actually formulate all of these learning methods and skills directly into an algorithm and implement it on the robot, and also the learning procedure. So similar to a student and a teacher, we as a teacher try to show the robot how to perform and accomplish a specific task.
Robot basically should understand the first environment, then second the human factor and how human affects the environment, and finally how humans change the environment. And after that, it should extract the relative information from this demonstration to basically reply the same thing but with different environments or with different elements.
Robots are precise and exact, but they are very, very hard to program, and automation itself is incredibly hard. The humans, on the other hand, are very intelligent and they are very self-aware and they are very cognizant, but they are usually clumsy and especially mechanically, they are not very precise beings.
If we trust the human's perception and trust the robot's accuracy and precision, we can, if we combine them, we can get a very good operator in the automation line.
The surgeon is not that talented or doesn't have that precise, let's say, mechanics to do a very precise surgery, do the small cuts or suturings or other stuff. Or maybe the humans are prone to shaky movements and whatnot. So here a robot comes and helps the surgeon to perform a very precise and even a teleoperation surgery from somewhere else or another close city.
In the current age, it's never the robot's fault because we don't recognize robots as conscious beings right now, and that means they can't do something wrong like that by their own account.
The robots themselves don't have any emotions, at least for now, and they most certainly don't have any problem with us. They don't hate us, they don't like us, they have no feelings toward us. So when an accident occurs, it's either because there's a hardware problem, sensors are broken or anything like that, or the robot is coded in an incorrect way, or the human being wasn't interacting with the system responsibly.
Most probably, the problem is related to not the robot, because robot didn't decide to cut this hand or damage someone. The robot should have the additional hardware limitation and the additional software limitation to not damage the human.
For example, if I buy a blender and put my hand in it and run it, like my hand will get blended, but that's not the blender's fault or the blender maker's fault, that's my fault. But if I just want to make a smoothie and the blender explodes, that's probably the maker's fault.
I believe potentially robots can anticipate what humans can do, because even though humans are incredibly complicated and nonlinear systems, they are, after all, just very advanced and glorified robots themselves.
So actually, there are some research going on there. Like there is, I mean, of course, this is not like how humans anticipate or understand each other's, but in robot sense, let's say. So one of the examples is like when the robots tries to generate a safe trajectory while like humans are in the area. Like let's say if you like think a waiter robot that has to carry a knife around the kitchen, in slowly with time robots learns that knife is dangerous and human doesn't like to be around the knife, and if you go near them with the knife, they will run away.
And with more powerful machine learning algorithms, more advanced technologies or better resources, yes, an intelligent enough agent or group of agents can participate human behavior or predict it into the future with acceptable accuracy rates.
I believe robots can improve the society in many fundamental ways. When I see a kid without a leg can walk again with a prosthetic leg that is utilized with reinforcement learning, That's kind of how robots help to the humanities, and this is why I excited to work on robotics. I believe that I can help the humanity.
I find it very exciting that the robotics is working in the real world and actually manipulating the physical world. And that is a very difficult problem and still in its very early stages as opposed to some parts of AI. Okay, beating the chess world champion is easier than moving the pieces on the board, right? So the difficulty of that problem really excites me, and it feels like there's so much potential here.
When I'm thinking about fully and trustable and fully functioning brain and machine interface, like it increases my heart rate. I cannot say anything.
We can manufacture the different types of mechanical structures. It doesn't excite. It doesn't help me to get fascinating. But whenever I try to control this different complex architecture, and whenever I work on this architecture, it feels me very good. I like actually the control AI and robots.
Well, I see robots as an extension of human beings and their capabilities. Robots can lift what we can't lift ourselves. They can go places we can't go ourselves. And they can collect data from the environment and understand things about the environment that we can't understand with ourselves. So they are basically improvements to us. They are an extension to us and our capabilities.